Now children, how to classify when you get few equations, how to classify into type of reaction and type of reagent. Okay. So for that, first of all, when you look at an equation, just observe what is happening. Okay. Is it substitution? Is it elimination? Is it addition? Substitution means number of atoms around that carbon, it will be same. Okay. Something new will be only coming in it. So number, just you look here, it is ethyl bromide. Now the first carbon is connected with bromine. In the product, the first carbon is connected with OH. So bromine got replaced by OH. So that shows it is substitution. Nothing extra is been added, only one has been substituted. Bromine has been substituted by OH. So we can classify this reaction as substitution reaction. Substitution reaction. Okay. Now what is the type of reagent? Look at the reagent, attacking reagent here. It is potassium hydroxide. So we know that hydroxide ion OH minus liberated from here will be replacing Br minus. So it is nucleophile. So the type of reagent is nucleophile. Okay. So that is the type of reagent used here. Now the second equation, look at it. You can see that it is ethyl bromide treated with alcoholic potassium hydroxide. Now look at the reactant and the final product. Reactant, there was bromine. Now bromine is replaced. Okay. There were three carbon is surrounded by 3 atoms, 2 hydrogen, 1 bromine. Here also carbon surrounded by 3 atoms. But now look at their product. Carbon is surrounded by 2 hydrogen only. Okay. So it is missing 1 each item from each carbon. So something has been removed. That shows it is elimination. So the type of reaction here is elimination reaction. So this is how you find whether it is substitution or elimination. Now which is the reagent which is involved? From the reagent potassium hydroxide, it will ionize to give K plus and OH minus. OH minus is responsible for the elimination. So it is nucleophile. Okay. Type of reagent is nucleophile. Okay. Nucleophile is undergoing the elimination. Now look at the third reaction. It is acetaldehyde treated with HCl. Okay. In acetaldehyde, carbonyl group C double bond O group, there nothing has been removed. Everything is there. CHO, it is there. CHO you can see here. Plus HCN is getting added. HCN is getting added to the original reactant. So something is getting added. So at carbonyl group C double bond O, H and Cn got added. Okay, thus you are getting product. So it is an addition reaction. Type of reaction is addition reaction. Okay. Now which is the reagent bringing the reaction? It is cyanide. Cn minus is one which is responsible. So it is again nucleophilic addition reaction, or you can say type of reagent is nucleophile. Now look at the fourth one. Benzene treated with chlorine in presence of anhydrous ferric chloride. Now look at the condition here. It is anhydrous ferric chloride which is electron deficient. So it will undergo electrolytic bond fission. So chlorine will be undergoing electrolytic fission. One will be resulting in Cl minus, another will be resulting in Cl plus. Okay. So Cl minus will be taken by FeCl3 because it is deficient of electron. Cl minus combines forming FeCl4 minus. Okay. And Cl plus, which is liberated, now will be substituting H plus in the benzene and forming chlorobenzene. So here you can see that chlorine got substituted in place of hydrogen. So it is a substitution reaction. Now which reagent brought it? Cl plus. Cl plus which was being formed. Cl plus comes under electrophile. So it is electrophile which is bringing about the reaction. Electrophile or electrophilic substitution reaction. Now look at the fifth one. Methane is treated with chlorine in presence of diffuse sunlight or UV radiation or heat. Any such condition when you see, then the reagent will be undergoing homolytic fission. It will be undergoing homolytic fission resulting in free radical. Cl dot will be formed. free radical will be helping in the substitution. One H is replaced by Cl. Okay, thus it is undergoing substitution with the help of free radical. So it is substitution reaction brought about by free radical. So children, this is how we can locate whether it is which type of reaction and which type of reagent has been used for the different reactions. Okay, now here in short I want to explain E1 and E2. E1 is unimolecular elimination reaction, E2 is bimolecular elimination reaction. It is quite similar to SN1 and SN2. E1 is two-step mechanism. Two steps are involved in the mechanism. E2 is one-step mechanism. Okay, so rate depends upon the concentration of substrate only. Here rate depends upon concentration of substrate as well as attacking reagent. Okay, so first step is the slow step or rate determining step. Okay, this is the slow step. Now in slow step, usually tertiary alkyl halide we see that undergoes E1 elimination mechanism. Okay, now here it ionizes. Okay, here first step itself it will ionize and form a carbocation. It will be forming a carbocation. Okay, so positive charge is there in this carbon, and this carbocation formation or the ionization is the slow step. Now next step, second step, the attacking reagent will now approach the carbocation and it will be removing OH minus. We know that it usually elimination happens in presence of alcoholic potassium hydroxide. There is a strong base. Elimination needs strong base. Okay, so there will be base here, and OH minus, which is furnished from the compound, will be removing H plus. It will be removing H plus. Okay, it will be removing H plus and combines with OH minus to form water. And the bond here which broken as heterolytic, that pair of bond, pair of electron will be given here to the carbon with positive charge, forming a double bond. Thus a double bond results here forming an alkene. Okay, alkene and water is formed. Now E2 mechanism is a single step mechanism where the attacking reagent attacks the substrate from the back side and removes the adjacent hydrogen. H plus has been removed. Okay, the pair of electron between carbon and hydrogen is now given to this position, forming a double bond. Okay, at the same time X will leave the compound and it will be forming a double bond. The electron X will be taking the pair of electron, and now carbon gets the pair of electron from here and it is forming double bond. So H plus, which is removed, combines with OH minus, forming water, and X minus is removed. Now in E1 and E2 we see that rate is first order reaction in E1, and E2 rate is second order reaction. Okay, rate is proportional to concentration of substrate. It is rate is proportional to concentration of substrate and attacking reagent. Now E1 usually favors with high temperature. Okay, high temperature. E2 temperature is not much a criteria. E1 polar protic solvents are used. Okay, polar protic solvents like water and all polar protic solvents are used, whereas E2 polar aprotic solvents are used. Now E1 weak bases is enough, whereas E2 is always favored by strong base like sodamide, alcoholic potassium hydroxide, then alkoxide in alcohol, so on. Strong bases will favor E2 mechanism or E2 reaction. Now even better leaving group is required. So we can see that if it is a better leaving group, it will leave off the substrate and form carbocation easily. Here it is not that much required. Okay, poor leaving group is enough for E2 mechanism. So that's the difference between E1 and E2 reaction or its mechanism.